Hello everyone and welcome back to our channel A to Z Automation in Java. And in previous session we have discussed about modifiers in Java, and in that we discussed about access modifiers. So in access modifiers we discussed about public, private, protected and default, and what they are doing. They are deciding the accessibility of different variables, methods and class among the different packages and at the project level. So now today's topic is non-access modifiers in Java. Okay, non-access modifiers provide information about the characteristics of a class, methods or variables to the JVM. Okay, they didn't decide the accessibility. They just provide us the information about the characteristics of a class, method or a variable to the Java virtual machine. Some of the major types of non-access modifiers which are basically used are static, final and abstract. Okay, if we talk about so we are discussing about non-access modifiers. Non-access modifiers in Java. Non-access modifiers provides us information about the characteristics of a class. Okay, methods or variables to the Java virtual machine, to JVM. Okay, and the majorly and commonly used non-access modifiers are static, final and abstract. These are the most commonly used access modifiers, but there are 7 different types of access modifiers in Java if we talk about them. But the most commonly used are static, final and abstract. So if we talk about 7 different modifiers, there are total 7 different modifiers. Okay, there are 7 different modifiers, non-access modifiers. In Java. And what are those? The first one is static, second one is final, third one is abstract, fourth one is synchronized, fifth one is volatile, transient and native. So sixth is transient, seventh is native. But the most commonly used are these 3. Okay, so static, final and abstract are the most commonly used non-access modifiers. Okay, so let me discuss one by one each and every one. So the first non-access modifier which is used is the static. So let me discuss about the static non-access modifier. Okay, so static is basically we can call all of these as a keyword. These all are the keywords in Java. Okay, so if we talk about the static keyword, it means that the entity which is available to the whole class. Basically we can say that static means all the variables and methods. If we are using static keyword along with variables and methods in Java, then all those variables and methods belongs to a class, not to any particular instance. Okay, in previous classes we have discussed about instance and object. So if we are declaring any variable or method is static, then that variable and method will not belong to any of that instance. It will belong to the whole class. Okay, so we can say that static keyword means the entity to which it is applied is available to whole class. Okay, is available to whole class, or we can say that is available outside any particular instance slash object of a class. Okay, so if we are declaring any variable or method as static, then all those variables and methods will not belong to any particular instance or object. Okay, and we can say that static methods and the attributes are a part of a class, not an object. Okay, static methods and attributes, or the variables whichever we are declaring, are a part of class, not an object. Okay, the memory allocation to such type of attributes and methods happens at the time of class loading. Whenever we execute any class, suppose that we have created one class and we are going to execute that class, whenever that class loads in the JVM, at that time static variables and methods are created. Okay, the memory allocation to these methods and variables happens at that time whenever that class is being loaded in the JVM. It's not like that whenever we are calling any object those variables are getting created. These got created at the runtime. Okay, so we can say that memory is allocated to such attributes and methods, attributes at the time of class loading. Whenever the class is loading in the JVM, the memory allocation will happen. Okay, so what is the use of this one? Why we are creating the variables and methods as static? These are used because in this case we are saving the memory. How we can save the memory? Or we can say that the use of static modifiers makes the programs more efficient by saving memory. How we can save the memory? Let's take an example. Okay, let me take one example like this, that this is the class, and inside class we are creating three different objects: object 1, object 2 and object 3. These are three different objects. If we are creating instance variables or something like that, then that instance variable will have that value inside any object. Suppose if we are creating object A, object B and object C, so that particular instance variable will have that particular value inside this object A only. Suppose there is one variable B. Okay, there is one variable int f is equals to 20. This f is instance variable. So if we are calling this a dot f and we are updating the value of f to 34, so what will happen? This value of f is applicable only to this particular object in which I am changing the value. Okay, we are changing the value of f to 34 using object A. So we will get the updated value of f whenever we are calling the value of f from object A. And suppose we go in the object B, here in the object B, and we use the statement system.out.print b.f. So b.f will not get this updated value 34. What will happen? It will get the fresh value of f which is declared at the class level. Okay, so in this b.f we will get the output as 20, because the value which we have updated, we updated that in first object, not in the second object. So the value of f is equals to 34 will limit to only object A. It will not get reflected into object B and object C. Okay, that's why we can say here the use of static modifiers makes the program more efficient by saving memory. How the memory will get saved in this case? As you can see this example, if we are creating 3 different objects and we are using instance variables, then each and every time the value of f is getting updated and that is limited to this particular object, it means it is occupying space every time. In all the objects, this f is occupying different space. Okay, this is occupying different space here as well. If all of these are occupying the same space, then if we are updating the value of f is equals to 34, then that need to get reflected into the B object and C object as well. But in the B object we are getting the fresh value. It means memory allocation will happen again. Whenever we are creating object, the memory allocation will happen and all the fresh values will come inside all of these different objects. And what will be that fresh value? The fresh value of f will be 20 every time. Okay, so suppose now let's take an example of static modifier. So suppose we created one static int d is equals to 30, d is equals to 12. Okay, so now suppose if we are calling this d is equals to 24 from object a dot d. Okay, if we are calling a dot d here, what is the value of a? The value of a here is 12. So we will get 12 as the output. Okay, we get 12 as the output. Now what we will do? Let's update the value of a dot d is equals to 34. So now what will happen? As we are not copying all the variables inside the different objects, this static variable will be created only once. Okay, what time it will be created? Or memory allocation will happen only once. Memory allocation will happen at the time of class loading. The memory will not allocated every time whenever the object is created. There will be only one memory allocation will happen in this case whenever the class is loading. Okay, so the memory is got allocated to this d variable. And now what we did, we updated the value of d to 34. So what will happen now? So this value of d will get updated here now. Now 12 will get removed and it will get updated to 34 now. As it belongs to class, it is not belonging to any of this object. So whenever now we will go in different object, and if we call b dot d, so what will happen? Now as the value of d is already updated, now it's not displaying d is equals to 12. it has the updated value of d now. What is the updated value of d? D is updated value is 34 now. So here what will happen, it will display 34 now. It is not going to display 12 because that value is not belonging to any object. In the previous case, whenever we are creating instance variables, the value is limited to object only. Okay, it is not affecting the variable at the class level. It is affecting that value inside the object only. But whenever we are declaring any variable or method as a static, then that static variable is not bind to any object. It is bind to class. So whenever we are doing any updation to that value, it will get reflected directly inside the class, and it will reflect in all the different objects whichever we are creating. Okay, so suppose if we are now going to call this same d variable from c object, c dot d. So what will happen? It will display the updated value. What is the updated value? Last updated value is 34. So it will display 34 now in this case. Okay, and suppose if we are going to call f here, and if we call this f, what is this f? F is not the static, so it will pick the fresh value of f, which is at the class level. What is the fresh value of f at class level? The fresh value of f is 20 at class level, so it will pick 20. It will not pick the updated value which we updated in the first object, as the instance variables are basically bind to the object only. So whatever changes we are doing in the instance variable will reflect inside that object only. It will not get reflect into different objects. But if we are doing the updation in any static value, then that will get reflect in all the objects of the class. Okay. Yeah. Okay, let's move forward. And a static field exists across all the class instances, as we already discussed. Now what we can do is that we can access the static variables and methods without the object. As in our case, as of now, what we are doing, suppose if we want to call any variable or method anywhere inside any method, then we need to create the object. But now if we are creating any variable as a static, if we create any variable or method as static, then we can call these variables and methods without using object of that class. How this will happen? We can call them using the class name. They can be called using class name only. Okay, they can be called using class names. How we can use this thing? Suppose, let's take an example that this is the static variable. Okay, this is the static variable int d is equals to 34. And now if we want to call this variable inside any other class, let's take an example of this another class. This is another class and we want to call this d variable inside this class. So previously what we were doing in the previous classes, we just go and create the object of this particular class whose variable we want to call inside another class. We create the object. But now in order to call the static variables and methods, we don't need the object. We can just directly call them using the class name. Suppose the class name here is test. Okay, so and this class is test1. So if we want to call the static variable or method of test class, then we can directly call them using the class name like this, test.d. We can directly call this d variable of this test class. Why we are able to call this directly? Because we are creating it using the static keyword. If we are using the static keyword, then we can call the variables and methods directly using the class name only. Okay, let's see the live example of this one, how we can do this. As of now, I think everyone is clear about the basic properties of the static keyword. What is that one? Static variables and methods belongs to the class level, not to any particular not to any particular object. It means that whenever we are doing any changes to any variable or method, then that will get reflected to that particular variable at the class level. It's not bind to any object. Okay, if we are doing any changes anywhere, then that will get reflected into all the objects which are being created inside the class. Another thing is that static variables are created only once, or the memory allocation happens only once. At what time the memory allocation will happen? At the time of class loading. This happens. Okay, and another last point is that we can call the static variables and methods directly using the class name. We don't need the object of the class if we want to create the variables or methods, or if we want to access the variables or methods which are being marked as static, then we don't need to create the object. We can directly call them using the class name. Okay, let's go here and see the example of this one. Okay, let's see the example, as this is the test class. So now just create two variables inside this one as static and one as instance. So we have created two different integer variables, int variables, and let's mark one of them as static. Okay, and now just create two different methods. Okay, the first method is m1 method, and now let's create one more method and mark it as m2 method. Okay, and now let's mark it as static. This method is static method. Okay, so suppose if we want to call these variables and these methods which are not static, so we have seen this thing in the previous class, that what we need to do, we need to create the object of the class. If we want to call the instance variables anywhere, then we need to create the object of the class like this. Okay, and then we can use the reference of this object and we can call the variables like this, a, m1 and all those, and we will also see this b and m2 as well. But in order to call the variables and methods which are not static, we need to create the object. This is the mandatory point. We need to create the object of that class. Okay, and suppose if we want to call the static variables and methods, then it is not mandatory to create the object. But if we are creating the object, then it will also get displayed. Okay, as you can see here is that we have created the object and we are using the reference of the object. Then also we can see these static variables and methods. Okay, but it is not mandatory. If we don't want to create the object of the class, then we can directly call these static variables and methods using the class name. Okay, suppose if we want to call them here, then we will use this class name and press the dot. You can directly see these static variables only. We are not able to see this a and m1 because a and m1 are not marked as static. B and m2 method are marked as static, then we can call them directly here. Okay, and suppose if we are going to execute this one, then it will get executed like this. Okay, this is being called, and we didn't created the object in this case. So it can be called in the same way inside any other class wherever we want to call this. And one more point here is that if we want to call these static variables inside any other method or any other variable, then there is one property as well. We can call static variables and methods directly inside the static methods only. What we can say is that suppose this is the integer a, then we can call this a inside any method which is static or non-static. Suppose if the first method m1 is non-static and another method is static method, so if we want to call this a inside m1, then we can call it directly, because this method is also non-static and we are calling this non-static variable here. And we can call this non-static inside the static method as well. This is the issue. We cannot call the non-static variables and methods inside the static area. Okay, we cannot call we cannot call non-static variables and methods inside the static area directly. Okay, we cannot call. We can directly call the static values inside the static area only. Suppose this is the static method m2, then we can call the static values. This is the static, then we can directly call this b inside this method. Okay, and if we want to call the non-static values as well, then what we need to do? We need to create the object of the class in this case. Okay, we can create the object of class. Okay, now you can call the non-static variables as well, this one, and we can store it inside any other variable like this. Okay, now it's okay to call this variable. But suppose if we want to call the static variables and methods inside the static area, then it is possible directly. We can call them without creating the object. But if we want to call the non-static variables and methods inside the static area, then it is not possible. In order to call the non-static values inside the static area, we need to create the object. This is the mandatory point. Okay, so this is all about the static keyword.